So this is the video for chapter 6, the estimation. So today we are going to see how researchers would use the statistics obtained from the sample to make educated guesses about the corresponding parameter in the population. So let us refresh our memory about the statistics and the parameter. If you go back to the chapter 5, page number 95 of the book, you are going to see that the statistics is about the sample. When you have the numerical values that correspond for the sample is called the statistics, and when you have it correspond to the population, it is called parameter. You should also make note of the table that is given, the table 5.1, with the difference in the various symbols between the statistics that is in the sample and the parameter in the population. This concept is revisited again for the chapter 7 hypothesis testing also. So the difference between the statistics and the parameter should be very clear. So the answer for the question is, should we expect sampling error when a random sample is drawn, is yes, we will. There would be some sort of a sampling error. Now, the same example that Hug talks about flipping the coin 20 times is, suppose he keeps on flipping the coin 20 times, and every single time when he gets the proportion of the heads, which is his statistics, he sees that that is different every single time. So on. So he would say, hey, I found that the proportion was very different single time. So if you look at page number 117, each of the bars show the sampling distribution of the number or the proportion of heads in 20 flips of a coin. So each bar represents the coin being flipped 20 times and the proportion of heads being calculated. And this is called a sampling distribution. Sampling distribution is a frequency distribution showing the results of multiple random samples of the same size drawn from the same population. So here the same size is the 20 flips. And so those are multiple random samples because we flipped it multiple times, like you did multiple 20 times and you did the bars for the proportion of heads. This is called a sampling distribution. So you have to make note of the fact that all the experiments have exactly the same number of trials here. That means 20 flips. The sampling distribution is recording the statistic for each sample when multiple samples are taken. So if we are talking about doing an experiment and collecting data from our own classroom, say that would be one sample and the statistics I get from it. And if I would repeat the same experiment with another class and get another statistic, that would be my second value. And I can conduct this sampling as many times I want. I will end up having a table or a distribution of the statistic obtained from each of the samples, and this is the sampling distribution as we talked about. That means you have a list of values for that particular statistics. The standard deviation obtained from this list of statistics is called standard error. I remember that we were talking about there is a difference between standard deviation and standard error. When you talk about standard deviation, you are talking about one statistic, one sample, and the deviation of the mean, deviation from the mean, plus or minus. But in this case, the standard error denoted by SE is actually the error or the deviation of the different samples. The sampling distribution is what we are talking about over here. So if you look at the table that is again on 117, the bars are showing you it is the sampling distribution. So if I calculate the standard error of mean, in which this is my different values, and we calculate the mean of these items in the sampling distribution. So 10 times that mean is going to give us 10 different means, right? So I have one sample will give me one mean, the second sample will give me a second mean, the third sample will give me a third mean. And so the deviation of the means would actually be your standard error. So this is what is the difference between the standard error and standard deviation. Now we are going to talk about, let me move my cursor to the confidence interval. I forgot one small little detail about the standard error. So let us go back and look at page number 119, the 6.1 and 6.2. If you look at those, you are going to see the different ways of representing the standard error. For example, on page number 120 also, you are going to see in the excerpt 6.3, the standard error is represented as a bar graph. So once again, the sampling distribution is the frequency distribution that shows the result obtained for the value of a particular statistic under our focus when the experiment is repeated several times from using the samples drawn from the same population. So you're drawing different samples from the same population, you're doing the statistics, and that statistics is the graph. Standard error is the deviation of all those values that we obtain in the sampling distribution. It is sometimes not practical to repeat the samples again and again. So the sampling distribution and standard errors are usually calculated using statistical methods. Standard errors are reported in passages using a text, table, or graph. So that is something I wanted to make sure you guys see. The different types is the percentage and the way it is done. Now let us look at confidence intervals. Confidence intervals are usually represented using an interval with a lower bound and an upper bound stated either in words or inside parentheses separated by commas or a square bracket. Every confidence interval will have a percentage value associated with it. Usually the value is 95%. Sometimes it could be 90% or 99%, depending on what the researcher would associate the confidence interval with. They are constructed from a statistics which could be a mean or a proportion of a standard deviation. With any statistic from the sample, a number which will be the product of the standard error that we discussed before and a number corresponding with the percentage associated with it will be either added or subtracted, which will in turn give us the lower bound and the upper bound. So you have the statistics plus or minus the number associated with the percentage and the product with the standard error. It gives you, minus would give you the lower bound and the plus would give you the upper bound. There are 4 things associated with the intervals. One is the statistic itself, then is the sign. If it is negative, like I said, it would be the lower bound. If it is positive, then it would be the upper bound. The number associated with the percentage, which usually comes from the statistical table, and the standard error. Let us also see how we interpret confidence intervals in the right way. How do we interpret 95% confidence interval? So coming back to chapter 6, there are several methods to make an educated guess as to what the values of the population would be based on the values of the sample. One of those techniques is called estimation, and we will be talking about estimation in chapter 6. There are two different kinds of estimation. One is the interval estimation and the other is the point estimation. So let us start talking about the interval estimation. Before we start about the interval estimation, we want to know about certain statistical terms, and one of them is the sampling error. So what is sampling error? The sampling error is the difference between the observed statistics and the original value of the corresponding parameter. Remember how we talked about the statistic is from the sample and the parameter is from the population. So it is the difference between the observed statistics in the sample that the researcher currently has and then the original value of the corresponding parameter. We can only hope that the statistics that we have from our sample would exactly be the value of the parameter that we are trying to figure out from the population. But that need not always happen. And so how far it will be away from the parameter is again dependent on many factors. However, make sure we do not misunderstand the sampling error as some sort of a bad thing that has happened during the estimation. The researchers have to be careful when collecting the sample, but there is always a big chance of having a very big sampling error, depending on the sample that we chose. Well, if we take all the precautions to make our sample as close to the population, as perfect as possible, using all the techniques that we've talked about in our previous chapters and the previous classes, there is still a chance that some sort of a sampling error will happen, and it is very natural. And so please do not misunderstand for it to be a defect of the sample. So look at page number 115. In this example on page number 115, Hub talks about flipping a coin 20 times, a quarter 20 times. I do know what happened. Like, he talked about 10 times heads and 10 times tails, but when he actually flipped the coin, he had 13 heads and 7 tails for a statistic of 0.65. The difference between the sample statistics and the population parameter is the sampling error. Once again, like he says, that the term sampling error does not indicate that the sample has been extracted improperly from the population or that the sample data has been improperly summarized. Even if the proper sampling techniques and data procedures are used, sampling error ought to be accepted. It is not attributed to any mistake that's made, but rather to natural behavior of the samples. With the mean of 53. So it does not mean that the parameter corresponding to the mean in the population would lie between 50 and 56. We have a 95% confidence intervals with 53, and this is a common mistake that we say is that the parameter corresponding to the mean would lie between 50 and 56. Instead, you have to understand that the confidence interval was obtained from standard error. And so in standard error, we took several samples from the population and calculated the statistics. Let's say we took 1000 times and created the 95% confidence intervals for each of the samples. Then this means that 95% chance, that is 95 out of 100 times, we will see that this would be the parameter obtained. So it is not that it lies between 50 and 56, it is that 95 out of 100 times we will obtain the mean of 53, the population parameter. We have to understand that this confidence interval is much stronger concept than the standard error, because it provides us a method to compare between the statistics of one group with another group. We usually expect researchers to report either the confidence error or the standard error in their research. If we know the standard error, we can always calculate the confidence interval for any percentage we want. Only restriction is the sample size should be more than 30 to successfully calculate this. We have to understand that a good researcher will always either report the confidence interval or the standard error, or once again when the researcher reports and there is a 95% confidence interval, to generalize, if I say there is an nth percent of confidence interval for a particular statistics taken from the samples, the various samples, then the lower limit, bracket, lower limit, comma, the upper limit are the two numbers. They basically mean that the data interval taken from the sample extends from the lower limit to the upper limit, and the chances are n out of 100 that this interval is one of the many possible intervals taken from the different samples of the same population that would contain the parameter that we are looking for between the interval limits of lower and upper. The lower limit and the upper limit does not guarantee that the parameter will be between these two numbers 95 times. It only means that this interval that we are looking at is one among the different possibilities that would guarantee that the parameter lies between these two numbers with a 95% confidence, or as we were generalizing, with nth percent confidence. So this is what we talk about the confidence interval. So to summarize, the confidence interval is basically a range where we expect something to be there. When we say expect, we are also open to the possibility of being wrong. So the degree of confidence measures the probability of that expectation to be true. The degree of confidence is linked to the width of the confidence interval. So if it is 95%, that is my degree of confidence for where I expect something to be there. It is very easy to be confident within a very wide range, and very difficult if you have a very small range. That is why the amount of information has an influence on the degree of the confidence and the width of the confidence interval. With more information, we are more confident. We will be more confident within that given interval. So that is why your sample size has to be at least minimum of 30. And with more information and getting degree of confidence, we can narrow the interval where we expect it to be wrong. So the second way of doing estimation is the point estimation. The power of point estimation is much less when compared to an interval estimation, because as we know, there is a high possibility or high probability of point estimation going wrong. Usually, point estimation are used to report reliability and validity coefficient. We calculate the values of reliability and validity as numbers and not as intervals. Sometimes some researchers would represent it as a confidence interval. If confidence intervals are built around reliability and validity, then the researcher did a thorough study and needs to be applauded. When the researcher tries to build a confidence interval, they can rely upon certain point estimations like standard deviation to construct it. In that way, point estimation is very relevant. However, as your book notes, with point estimation, there is no level of confidence must be selected, no statistical table must be consulted, and no interval must be created. Researchers simply compute the statistics on the basis of the sample data and then postulates that the unknown value of the population parameter is the same as the data number. So now this is something, that is why, like in the interval estimation, the researcher selects the level of confidence, 95%, analyzes the data, extracts the number of the statistical table, scientifically builds an interval that surrounds the sample statistics. That is why point estimation is much less than that of the interval estimation. Interval estimation is much more powerful than the point estimation, because it gives us the number corresponding to the statistic based upon which the researcher would say that this is the value of the statistics, and therefore the parameter is more likely to be very close to this point of value that we have determined from the sample. Internal estimation either gives us the standard error or it gives us the confidence interval, which is more accurate than the point estimation in estimating the value of the parameter based on the statistics obtained from the sample. In either case, interval estimation or the point estimation, the researcher is making an educated guess using the statistics that he obtained from the sample using the statistical techniques. Let us now look at some of the warnings about concerning estimation. The first three warnings would be about the interval estimation, and then the last warning is about the interval and the point estimation. So one thing is, when we read our literature, we come across the situations where the two numbers are separated by a plus or a minus sign. Usually the first number would be the statistic like the mean, and then the standard deviation, and the number succeeding the plus or the minus sign would, there is a chance that we may think it is the standard deviation, but it also could be the estimated standard error. So be careful about estimating what the second number means, and it is also important to read through the literature to actually identify what they are talking about. The second thing is that we should be careful about the fact that standard errors can only be estimated. It cannot be determined. In real situation, only one sample is taken and then the standard error is estimated through some statistical procedures. So it is only to be estimated, it cannot be not determined. Now, one of the most common misunderstanding about the confidence interval is the confidence interval starts with the lower bound and the upper bound, and the formula says that it starts with the statistics and go certain points to the left and certain points all the way to the right, implying the statistic will be in the middle of the interval. But that may not always be the case, especially when we are considering R, which is the Pearson coefficient. So the last one that we are talking about is neither interval estimation nor the point estimation can be expected to work if we are based on a non-random sample. They may not work. This concludes the chapter 6 of your book. If there are any questions, please do not hesitate to ask.